Hello everyone. In today's lesson, I'm going to be discussing determining chemical formulas. This is actually section 4 of chapter 7, page 233 in my book. Okay, so without further delay, let's start by defining empirical formula. Now, what do we mean by empirical? Empirical means, empirical formula means it consists of the symbols of the elements combined in a compound with subscripts showing the smallest whole number, mole ratio of the different atoms in the compound. So what does that mean? It means that it is the basic structure of a chemical formula. So, and this is how we guess it. When we guess it, it's called the empirical formula, but we don't just guess it, without, following, um, uh, let's say, it's not just something that you just guess, like that out of the air. No, it's based on information that we will come to show you later. Now, just notice that for ionic compounds, the formula unit is usually the compound's empirical formula. So if we're trying to find the empirical formula of an ionic compound, a metal and a nonmetal together, usually the empirical formula is, and this is a note that I write over here, so the empirical formula is the same as the chemical formula, but for molecular um, compounds, it can be the empirical formula, okay? The chemical formula can be the empirical formula, or a multiple of the empirical formula, and that's EF is just stands for empirical formula. Okay, without further delay, let's look at some notes here I made. So our objective is to determine a compound's empirical formula from its percentage composition. Okay, from 7.3 we know what percentage composition means. So if we have an example, let's say, given the percentage composition of, okay, given the percentage composition of diborane is 78.1% of boron and 21.9% of hydrogen. Find the empirical formula of diborane. Okay, the first step is that you're going to assume that you have 100 grams of diborane. Okay, so assume that you have 100 grams of that compound. And then step 2 involves finding moles. So we're going to find moles using triangle number 1, which is grams, molar mass, and moles. So if I have 100 grams of diborane and I have 78.1% of boron, that means I have 78.1 grams of boron, and I have 21.9 grams of hydrogen. Now, since I have grams right now, this is what I have, okay? So I have grams. If I divide it by the molar mass, for every atom, I will get the moles. So this is our second step. So we're going to divide every mass by its molar mass, and we get the number of moles over here. So we did that the same. Of course, we get these numbers from the periodic table. After that, we find out that the ratio is 7.22 moles of boron to 21.7 moles of hydrogen. Step 3, divide by the least number of moles. Divide by the least number of moles to get the smallest whole ratio. Okay, we need to find the smallest whole ratio. So 7.22 to 21.7, if we want to minimize that, Okay, and keeping whole ratio, of course, we need to divide by the minimum or the least moles. So as you notice, 7.22 is less than 21.7, so we're going to divide by this number. And if we divide by it on both sides, as you can see, we get, it's a 1 to 3.01, okay? So it's a 1 to 3. In other words, it's a 1 to 3 ratio. That means I have one atom. Remember, in chemical formulas, the moles, the subscripts represent moles, okay, when we're doing stoichiometry. So 1 to 3, that means I have 1 boron, okay, and I have 3 hydrogens. Remember, this is the side of the hydrogen, all of these calculations all through. Okay, so the empirical formula, we inferred that the empirical formula is BH3. As you can see, 1 mole for B, 3 moles for H. We have a note over here. X multiplied by empirical formula equals molecular formula. So if I know, because remember what we said about molecular formula? Molecular formula is like the final formula for a compound. And it's usually either the empirical formula, now we're talking about molecular, we're talking about compounds that are not ionic, okay? We're not talking about ionic compounds because we said that ionic compounds have usually the final chemical formula is the same as the empirical formula. But for molecular compounds, we said that it is a multiple. So it can be the same as the empirical or a multiple. So X is just when you like multiply by 1 or 2. So it's an integer, okay? X is a positive integer. So basically, if I know X and my empirical formula, I can find my molecular formula. And we're going to give you another example on how to work these out. The first step is to find X. Now, X is given by this formula, molecular formula mass divided by empirical formula mass. So molecular formula mass, this is for the final chemical formula. This is going to be given for the final chemical formula, and this is found by experimentation. Okay, this is found by experimentation. Empirical formula mass is just the molar mass of the, for instance, the empirical formula you find by calculations. So usually in questions like this, you will be given the empirical formula and you will be given the molecular formula mass as a number with the unit of grams per mole. So all you need to do is find the formula mass or the molar mass. Guys, this is the same as molar mass, okay? So formula here, same as molar. These two words are the same. So we're going to find the molar mass of the empirical formula. Let's say if we're trying to find it for BH3. So you just add 1 boron to 3 hydrogens. You find that and you divide these two numbers, you get X, and then you multiply X, that's your factor. And then you multiply X by the empirical formula, and then you get a multiple of the empirical formula, and that is your final molecular formula. Okay. I have a sample problem N, page 223. In the example, you're given the empirical formula of phosphorus and oxygen, which is P2O5. Also given that experimentation shows that the molar mass of this compound is 280.9.89 grams per mole. The unknown is the molecular formula of the compound. Our plan is to find X by applying the previous formula. Step 2, multiply X by the subscripts of the empirical formula. And this is what we did. We're finding X over here. we divide, this is given, and this is calculate this, okay? So it's for phosphorus and oxygen. We have 2 phosphorus, this is for phosphorus from the periodic table, times 5 oxygens, 16. And then we find out that X is equal to 2. So we're going to multiply our empirical formula. Remember, this is your empirical formula by 2. So you multiply the subscripts. 2 times 2 is 4, 5 times 2 is 10, and this is your final chemical formula. Remember that the molecular formula is a multiple of the empirical formula. For example, if we have an empirical formula of AB2, the possible molecular formulas can be, if it's multiplied by 2, then it's A2B4. If it's multiplied by 3, it is A3B6. If it's multiplied by 4, it is AB2, 5, etc. Okay, so this is how we solve these problems. Thank you for watching.